Hassler here. I just want to go ahead and give you some notes, some review for this FRQ set number 3 to get you set up for success as you work through the problems. So these are pretty much guaranteed on the free response section of your AP Calc test. Typically, they give you a graph of a derivative, and then they ask you questions about the original function. Or they like to give you a defined integral, like g is equal to the definite integral of f, but then they ask you questions about g in relation to f. And so, again, guaranteed when you look at our set list. I had highlighted this as being something that was on the test every year on the non-calculator portion. And so they like to ask you some very similar questions, and those are related to mins and maxes, increasing, decreasing, concave up, concave down, points of inflection, all that stuff that we've already talked about. In addition to that, they like to, like I said, give you a defined definite integral and ask you questions based on that defined definite integral. And they also like to throw in extreme value theorem. So I'm just going to give you some reminders on those to help get you started. All right, so just as a reminder, if you want to find information about f, for example, you might want to find where f of x has a minimum value. That occurs when the derivative equals 0 and changes from negative to positive. If you want to find where f of x has a maximum, that happens when your derivative is equal to 0 and changes from positive to negative. If you want to know where your function is increasing, that happens when the derivative is positive. And if you want to know where your function is decreasing, that happens when your derivative is negative. Now, I just want to note something here. So when you're talking about mins and maxes, those are one x value or two x values, but it's just an x value, versus this is an interval of x values, okay? The interval where I'm increasing or the interval where I'm decreasing. And so your answers will either be a single x value or an interval of x values, and it depends on what is being asked. Okay, so you could also be asked to determine where f of x is concave up. That happens when the second derivative of f is positive. That also happens when the first derivative of f is increasing. You could be asked when f of x is concave down. That happens when the second derivative of f is negative or the first derivative of f is decreasing. And again, these are going to be intervals of x whenever you go to answer those questions. Sometimes they like to combine it. They like to say, on what intervals is f of x both increasing and concave down? So you would have to look at both conditions, and where both conditions are met would be your answer. And again, both of those would be using intervals of x's. You might also be asked to find where f of x has a point of inflection, and that's when the second derivative changes signs. Yeah, the second derivative has to equal 0, but that's not enough. It has to be that the second derivative changes signs, either from positive to negative or negative to positive. All right, so those are all things that we have discussed and reviewed. I might as well just say this here. This would be an x value, like a single x value would be your point of inflection. Okay, so to go back to what I had mentioned earlier. Earlier I had said that you would be given a g function or an h function. They like to use g and h here. Given that g is equal to the definite integral from a to x of f of t dt. Now they could change it and say g in the definite integral of h, or h in the definite integral of f, or whatever they feel like making it that day. But this is the gist. If you have this setup that g is equal to a definite integral of another function, then recall, if they ask you to evaluate g at a specific number, we'll say g of b, that is equal to the area, in this case, under the f function, because that's the function in the integral, on the interval from a to b. And sometimes you have to consider that there might be an initial value, right? So be sure to include or think about an initial value that is in there. Okay? If that's something that pops up. It won't always pop up, but it might be something that pops up. And so if it is something that pops up, then that needs to be included, right? So if g is the area under that f function, that's the definition of a definite integral is area, then if I take the derivative with respect to x of both sides of that equal bar, I'm going to get that g prime of b would be equal to f of b, right? We said fundamental theorem of calculus states that the derivative of a definite integral, that's this right here, the derivative of a definite integral is equal to the function that I'm taking the definite integral of, and in that process, x replaces the t. Okay, so if I'm evaluating g prime of a number, that's equal to f of that number. And similarly, if I take the derivative of both sides again, then the second derivative of g at a number is equal to the first derivative of f at that number. And so this is something that they like to throw at you. I think in the last 6 years, half of the problems or 2 of the 6 problems, they defined g as the definite integral of f. Okay, and so I feel like it's possible that they throw that out at you. The last thing that I want to review with you today is EVT, extreme value theorem. And extreme value theorem is mentioned when you're looking at absolute extreme values. I'm going to say absolute extrema on a given interval. Okay. And so remember that if you're going to have to apply the extreme value theorem, the first thing that you want to do is you want to identify the derivative being set equal to 0. And that's because you're looking for the critical values of f. Okay. And after you identify the critical values of f, by the way, that also might be where the derivative does not exist. But usually it's just where the derivative is equal to 0. After I identify the critical values, then my job is to evaluate the endpoints for the interval that is given and the critical values that I found in step 1 for the function that they want you to use. So extreme value theorem, if I'm doing this for f of x, then to find critical values, I set the derivative of f equal to 0. And to create my table, I evaluate the endpoints and the critical values for regular f. And then I need to answer that question. And so that's your third step. Oops, I wrote 2 instead of 3 there. All right, third step, make sure you go back and answer the question. Sometimes they want an x value as the answer, and sometimes they want a y value as the answer. And so you just want to make sure that you are giving them what they are asking for. All right, so that's the review that I have for you on the free response set number 3. As always, make sure that you check the answer key, and then you are prepped and ready to ask me questions.